Welcome again. Good morning. For the third lecture, today we're gonna cover a review for MATLAB today. So we're gonna go back and revisit some of MATLAB functions and things that you've already learned in Comp 1, because definitely we'll be using these features of MATLAB in the coming chapters. So we're going to go over the lectures, and while I'm going through the lectures, I will be opening MATLAB and start working on them. And I would love from you also to do the same thing, where you open MATLAB and you start doing the examples in the lectures, just to get you going with the program, and all those features you've already done from, again, previous course. Just want to make sure that you review with me all these functions and all the features that MATLAB has. So I'll start with the lecture. So let me share this screen with you with the lectures, and we'll talk about the lectures, and then we'll start doing also some of the problems using MATLAB. So I just to show you here, I did open MATLAB in here. So this is, let me just move my pictures out of there. So if you look here, this is when you open MATLAB, this is what you get, the defaulted screen, where you have the command window here, you have the current folder, and you have the workspace. And just remember that you can definitely work on the command window, do all your commands in there, and if you're doing, for example, multiplication or addition or any of the functions, you can call this from this command window. And the workspace will give you all the variables that you have in there. For example, if you look here, you have X and Y. If you look here, you have an X and Y variables. And let me just do this here. Yeah, and yeah, on the left lower hand side here, right there, you will see that these are all the variables. You can always clear that. So we'll, as we go, we'll get reminded of some of these features that we'll use. But you know, I'm expecting that everybody should be able to know at least the basic stuff in MATLAB. This is the 2019 version of MATLAB. I'm not sure if when you took Comp 1, was it an older version or this, but they're pretty similar than the older version. Actually, it's more, they'll keep adding more features to this program. So we can work in the command window if you want, or you can also do this script file. If you look here at the new live script or new script, we can do that as well and save it as a file, and then we'll we can also just run it as a script file and get our analysis. So let's start with the lecture first, and then we'll come back to this here, just to reminder. So this is chapter 2. In overview, remember last chapter we talked about numerical analysis and problem solving, and we talked about something that we're probably gonna revisit later on. But before we do that, we want to start with the overview of MATLAB, and we'll talk about that defaulted MATLAB desktop. This is when you open it. As you can see, this is the current folder, and this is the command window in the middle. This is the command window. This is the current folder, and that will be the workspace where you save all these variables that you're working with. And if you look at the menu here, you will see that if you want to start a new script, just hit on that one right there. You can open new script. If you have a file or script already, you can open it if it's a new, or you want to open an existing file or existing function. You can do the saving of your workspace right there. When you open a script file that you've already worked on, you can hit run, and right there, run and time. You can always hit it and hit this, and you can run the program or the script file or the M file, and it will show all your results. Will show here in the command window. If you need help, you can go at the help, or you can just search your documents in this window. And this is something if you're looking for a function, particular function, which is something that you definitely you'll be doing, because I'm not expecting you to remember all commands, MATLAB commands. I don't expect you to remember all the MATLAB functions. So that's why you use this search documentation, and we'll use that later on as well. But this is exactly what you see when you open MATLAB. And we wanted to do is, we're going to work a little bit with the command window, but I need you guys, every time you have an assignment, a problem that you want to work on, you always open a new script right there, and you call this script the problem with the problem number that you have for that homework, and you save it. And that's why you save all your work, and you put them all in a after you save all the M files, you put them all in a zip file, and then you upload them on Canvas. So even though we're gonna do some work on the command window, but definitely every time we run a program or we run an analysis or a problem, we wanted to always open a new script file and save it in that current folder. So this is something, again, you've already seen. We're just going to talk a little bit just to review some of the commands. So for MATLAB, retains your previous keystrokes, so you can always use the up and down arrow key to scroll back through the commands. So if you enter an equation, for example, in the command window, and you want to go back to that equation, all you have to do is use the up arrow key to go back to your command and to that particular equation. So you don't have to retype it again. You don't have to retype the command. So that's a very handy feature that we use. You can press the key once to see the previous entry and so on. Use the down arrow key to scroll forward, edit a line using the left and right arrow keys and the backspace key. So this, and also the delete key. So you can always use those keys to navigate through the lines of your code. You can also press the enter key to execute the command, or if you have the program, you can just hit run and then it runs the program if you have a script file. These are some scalar arithmetic operations that we widely use it. You see the exponential, use the caret, and then you have the star, we use the multiplication, and the right division and left division. So you can use it, you can use both as well. And also the addition, a plus b, a minus b, the same thing that we've already, again, definitely been exposed to in Count 1. This is an example. So this is, we're just using the command window. So 8/10 is 0.8. It gives you the answer. You can, it automatically, MATLAB will save answer as is that variable. And you can always use that variable again. If you multiply it by 5, 5 times 0.8 would be 4. R would be equal 8/10. R is equal to 0.8. So you can, S is equal to 20 times R. So you can remember, every time you have a variable, you define a variable, MATLAB automatically save it in that variable window. So unless you redefine that variable. So in this case, for example, R is, since you calculated R is 0.8, so it is saved with this value. So S is equal to 20 times R, which is 0.8. So once it's saved, it's saved. It won't change until you change it yourself or you define it, redefine it yourself. Order of precedence, very important. You know, when you're working with with equations, you really want to pay attention to this. You know, parentheses evaluated starting with the innermost pair always. Second, we have MATLAB will look for exponential and evaluated from left to right. And third is the multiplication and division equal precedence evaluated from left to right. And fourth is addition and subtraction with equal precedence evaluated from left to right. So we gotta be careful. Sometimes, depending on the precedence that you put those operation, it will give you a different result. Now I'll show you an example in a minute. And what I really like from you, you're gonna be playing this. This is gonna be actually saved on YouTube videos, so you can always play those lecture videos. And if you are seeing this video, try to slow it down, slow the replay time, the rate, and try to work your program using MATLAB. Again, you open MATLAB and you do whatever has been done in this lecture. For example, you just open and start working on the workspace sorry, on the command center, and just do the same thing that's what we have. So you can just type 8 plus 3 times 5. And if you look at this, this is, it's going to give you 23 because 3 times 5 is going to go with first with the multiplication, then it will go with the, so that will be first. So MATLAB will multiply first, then it will add, and that's why we get 23. Okay, you can use the parentheses, it gives you the same answer because what's gonna do, it's gonna go and evaluate anything within the parentheses and then it will add that. Now, if you do this, if you flip the parentheses between 8 plus 3 times 5, you get different result because it will go and do the addition first, and then it does the multiplication. And the reason why it's doing the addition because you have the parentheses first. So the precedence of the will be the parentheses will be precedent to the multiplication. And same thing here for the exponential as well. So you can do that. It will give you also D0 if you change this. If you put the parentheses in there, it will give you also different type of answer. So this is something you can play with in your time, and just make sure you open MATLAB and start working. I mean, the idea beyond this review is to start you to operate the program and try to see if you're getting the same answer. Here, very much is also the same. 3 times 4 to the power 2 plus 5, you get 53. If you put the parentheses here between 3 and 4, right there, you get a different answer because it will do the parentheses first. So 3 times 4 will be 12. 12 to the power 2 is 144 plus 5 will be 149. So again, different precedents, you're gonna get different results. Commands for managing the work sessions. CLC, it clears the command windows. If you work in the command windows, try to clear it. You can use that. If you hit clear, it removes all variables from the workspace. So, and if you really do not want to remove all the variables, like you just want to remove certain variables, you can use clear and the name of the variables. In this case, I hit clear X, Y. It's removing the variables X and Y from the memory. Exist ABC determines if a file or variable exists having that name, and quit when you want to stop MATLAB completely. Who it's a list all variables currently in memo. Whose lists the current variables and sizes indicate if they have imaginary part. Now, column usually generates an array having regular spaced element. We're going to do that also as well. Run a lot of scripts using these. And a comma separates elements of an array. Semicolon suppresses screen printing, and this is something we mostly when you do write a program and you really do not interested in seeing certain values, because again, if you put, for example, x equal to without putting the semicolon, the MATLAB will present x equal to for you. If you really don't want to see that because you already define it in the workspace, you can just suppress that using the semicolon. Sometimes you really want to unsuppress that, and the reason why, because if you want to debug your program, you want to see how MATLAB is working. So most of the time, to see if you're making mistakes somewhere and trying to debug your program, you want to remove this semicolon that you inserted in there to see the results, see if you're doing the right thing. So very good feature, the semicolon. And the ellipses use it when you want to continue. If you have a long line and you want to go to the second line, you're not done with equations or you're not done with your command, you probably better off to just put those 3 dots in there. It will what it does, just continue the same line even though you start another line, so it won't interrupt your coding or your equation. So I mean, these are all commands that you are going to be seeing. There's tons of more commands in MATLAB. There's libraries of commands. You can always go to the help and it will show you definitely way more what I'm showing you in here. I can't, these are the most common commands that we use. So if you want to do more things and get exposed to more commands and to learn, definitely you can go to the library and see all of that. And it's a process. As we go, you learn more and you try to remember what also you've learned before and in Comp 1, sorry. Answer, again, if you put, for example, 3 plus 5 in the command window, it will give you answer equal 8. And it automatically will dedicate A and S as a variable. It's a temporary variable and it is saved in the workspace. EPS specifies the accuracy of floating point and precision. I and J are the imaginary units, which is square root of -1. We're going to be also working in imaginary numbers. And this is the beauty of MATLAB. It works, gives you a lot of latitude in dealing with imaginary numbers. And you'll see how easy it is to multiply and add and divide imaginary numbers. Infinity is INF. NaN indicates that undefined numerical results, and pi is the 3.14, the number pi. So these are all variables and constants that are used in MATLAB. Complex number operations. So for the number C1 is 1 minus 2i. You can enter it as 1 minus, this is here, sorry, 1 minus 2i. So you don't have to put the multiplication in there. The star, you don't really have the asterisk, you don't really have to use it. You don't have to do 2 times. Then you don't have to do that with the measurement. Just 1 minus 2i should be okay. MATLAB will know that it is an imaginary number. So you just have to be careful with the expression. So 7 over 2 times I and 7 over 2i. It is really, you know, it's the same. So if you have 7 over 2i, will give you a 3.5i. If you put 7 over the parentheses 2i, will give you a different number, which is minus 3.52i. And you know how to work with imaginary number. So the way you want to do that, you're going to multiply 2i over 2i, and then when you multiply I times i's, you're going to get I times I, you're going to get I squared, and I squared is equal to minus 1. That's why you have the negative in there. Okay, so depends on the parentheses. So if you want to solve the parentheses, you have this in the 7 over 2i. Again, you're going to have to multiply 2i at the denominator and numerator, 2i and 2i. And this is why you get 3.5. All right, so this is the complex, and we're going to do a lot of problems also dealing with complex numbers. Some display format, numeric format short is the 4 decimal digits, the default one. Format long give you up to 16 digits. And format short E, 5 digits, 4 decimals, plus exponent. And format long E is 16 digits, 15 decimals plus exponent. But you know, the defaulted one, usually when you do the calculation, we use that format short, unless you change it if you're looking to more decimal digits. Format bank is 2 decimal digits. Format plus, positive, negative, or 0 plus. Format RAT is rational approximation, so talking about quotients. And format compact is suppresses some blank lines, and format loose resets the less compact display modes. So these are all display format that can be used to display whatever you want on your screen. Again, this is what we talked about earlier. You see that this is the tool strip. You see all of this where you can start a new script, you save, you run. You can change the layout if you want. If you don't like it, you can definitely change that layout. And again, we talked about the search documentation. If you need help, you can definitely do that. I don't see this Simulink in there, but this is something you probably should see it in your copy. It's something also we're going to be working on later on in the semester as well. So arrays, and we're going to do a lot of arrays, working in arrays and also with matrices. The number 0, 0.1, 0.2 to 10 can be assigned by using this command here, where 0 and then you have the column, and then you have 0.1 and then column, then 10, which this is going to give you the initial number. This is the increment, and this is the final number. So in this case, using this command will give you from 0 to 10 with an increment of 0.1. So this is one way of creating an array. So that's an example. If you create u and you want to get to 5 times sine u for this value of u, so you can do this command here. And if you look at that, again, u is equal to 0, 0.1 is the increment, and 10 is the final value. So now we're talking about u as it has all these values, 10 times 10, so that's going to give you almost 100 values, 101 values, because we were starting from 0. And if you look here at the semicolon, the reason why we put a semicolon there, because we do not want to see all these numbers, because if you don't do that, MATLAB will actually show us all these numbers, and we don't really need to see them, just to save the space, your workspace. Now, W will be equal 5 times sine of u. And remember, you just want to remember that every time you have a sine or trigonometric function, they're all with radian, unless you changed it. You can always multiply it by 180 and divide it by pi inside, and that will give you radian. You actually convert from radian to degrees, but the default value inside that trigonometric function is in radian. Okay, so yeah, so that will be that's how one way of creating an array value. So you don't have to really retype those 100 values. Array index. Array index is very good because it really helps a lot. For example, when we had U has 101 values, and if you want to get the 7 values of that array, all you have to do is U of 7, again, parentheses 7, that will give you the 7 value of, remember, U is going to start 0, 0 0.1, 0 0.2, 0 0.3, 0 0.4, and also 0 0.5 and 0 0.6. So that's 1, 2, 3, 4, 5, 6, 7. So this is the 7 value of that array. So I just want to be careful if you, and that's something that you're going to use a lot in defining in programming. If you want to pick certain values of this array, you can definitely use this array index. Or you can do the same thing for the answer for W, and W, which is the value of 7, will be equal to 0.8232. You can use the length function to determine how many values are in an array. So in this case, if you want to define M as length of W, W is another array, and which is 101. It will give you the length of this array, which is 101 values. So these are all good commands and good tools that we use in MATLAB. So to find the roots of a function, we can definitely do that by using the roots command. So if you have a function, which is a cubic function, as this one here, x cubed minus 7x to the power 2 plus 40x minus 34 equal to 0. If you want to find the roots for that, all you have to do is look at the coefficients and put those coefficients in this form here. So you open a bracket, and 1 will be that coefficient of the x to the power 3, minus 7 is the coefficient for x to the power 2, plus 40 coefficient for 40x, and minus 34 is the constant in there. So one might tell me, okay, how about if you don't have coefficient for x? Maybe this value doesn't have, you just put 0 instead of 40. Okay, so very important to understand that these are the coefficients going from the higher higher exponential to the lower exponential. So, and you define that. This is the equation, and then just put, you use roots of A, that command, and that will give you the answer. And in this case, we have 2 imaginary numbers, and we are going to expect 3 solutions because it is polynomial to the power 3. So 3 solutions, 2 imaginary numbers, and 1 is a real number. Okay, so it's a great tool. It doesn't matter, you know, what is the polynomial that you have. You can have polynomial to the power 12, and you can really solve it that easy. These are some commonly used mathematical functions. So e to the power x is exponential. Use exp of x, square root sqrt of x, natural log, log of 10, cosine x, all these functions, mathematical functions that we use, sine of x, tangent of x, arc cosine of x, and all of those. And remember, all these functions, we use radian as the measure unless you convert to degree. I believe that the new function you can do maybe sine d of x will give you that degree. I know that they added this one a couple of years ago, so you can use sine d. I think sine d of x will give you this in degree. If you don't want to use the multiplication inside where you multiply by 180 divided by pi. So we'll try that later on when we open MATLAB. Anyways, so some MATLAB plotting commands, and this is something we are all definitely going to do as well. So x and y, when you open bracket and put x, y, Jim put n, it enables the mouse to get n points from a plot and returns the x and y coordinates in the x and y vector. So if we are trying to get a couple of points on a curve, you can use the ginput command to pull out those values, those data, with respect to x, y. And n will be the number of points that you really want to extract. The grid, it puts grid lines on the plot. G-text, it enables placement of text with the mouse. Plot, you know, that generates plot of the array y versus x on rectilinear axis. X label, text, it adds label to the horizontal axis, and y label, it does it for the y axis. And like I said earlier, you guys are pretty familiar with this. We've done this before. We're going to redo a couple of examples, also just to remind you of these commands, especially when we do some plotting. We're going to do some more complex plotting than this. So a good thing is to do this example here. So let us try to do this. Let me open MATLAB and do this plotting in there. So let's just do this one here. So what I want to do, I want to just get this one here, and I'm going to open MATLAB in here just to do here. Try to open this. All right, so this is MATLAB. So what I want to do, I just want to do that particular plot that we just saw in there. You can do that on your own as well. Again, the more practice you do, the better you will be at this. So let me just try to open the screen in. All right, so this is what we have. Actually, I can just move this one here. I want a little bit to the right. Okay. So I'm going to start with creating array for x. So I'm just going to do x equal. I'm going to start with 0, again, column 0.01, and then column let me see if I can. Try to actually enlarge the screen later on, but let me just do this, and this is equal to 7, the final number, and I'm just going to put semicolon to suppress the result, because I don't want MATLAB to go back and list all this array, because it's going to be a lot of arrays, because you're doing how many 0.01 increment from 0 to 7, so you might get 701 values. So that's one array, and the second array I'm going to do is y equal to 3 times cosine of 2 times x, right? And I'm also going to do a semicolon to suppress this, right? So I want to just now plot both. So I'm going to do just plot x, y, and that will actually give me, I'm plotting x, it will be the x-axis, y will be the y-axis, and also I'm going to do x label. I'm going to do the x label to be, when you do the x labels, you can just open a string here. And we're going to name it x. And the beauty of MATLAB, as you can see, if you see here, it says x label. It gives you the structure how this command should work. So again, x label, and then you put text. If you really want to find, put the string to C, it has to be that color, and then you close it with the parentheses, so you get a full color. So that's x label, x, and then also we're going to do y label, and you're going to also open a parentheses, and I'm going to open a string and put y in there, and close the string and close the parentheses. So now we have a plot xy, x label, and y label, and all you have to do is just hit enter. And by hitting enter, you will you should be able to get this figure here, right there. Okay. So one thing about this, the good thing about the window figure that you can definitely modify this, and let me just enlarge this a little bit. So you will see that it gives you this the figure. This is a sinusoidal function where y is the and the y-axis and x in the x-axis. Now you can actually modify this. There's a bunch of tools in the figure that you can use. You can insert title. You can insert. You can change the x label and y label if you want. So other than if you really do not want to do all of this in command, you can play with this after you do a basic command in the plot, and then you can modify it as well. You can save it in any format that you want. You can import the data. So there's tons of things you can do in that plot command window. So going back to this subject, I'm going to just close down this here, or just let me minimize this. So this is, if you look here, let me try to so if you look at this 3 lines in there, we created an array of x, created an array of y based on a function, and then we plot it. So this is done in the command window, but definitely you can do this in a script file, and that's why I expect from you when you do your plotting or you do your homework, you can open, and we'll do that later on, where you can open a script file and you save it and you just run it. And by just hitting run to that script file, if you type the same lines that you type in the command window, you'll be able to get the plot as well. But definitely that's what I need you to do. I need to always do it in a script file. All right, let's go back to the lecture. So let's just do this one here. Just move it here. All right. So, all right. So that's an example of plotting. Please try that in your own screen when you do Open MATLAB. Even if you don't do it while I'm covering this lecture, you can always do it in your own time. But this is just more practice that you need to do. So when you type a problem 1 in the command window, how does MATLAB, how does it go about executing this command? So the way it works, MATLAB first checks to see if problem 1 is a variable, because it will go to that workspace and see if any of these variables exist. If it doesn't see it, MATLAB then checks if it sees if a problem 1 is one of its own command. So maybe problem 1 could be like a sine function or something. So it goes and tries to see if it's in there. So if it's not there, then MATLAB then looks in the current directory for a file name problem1.m and executes that problem1. So problem1, when it is saved as problem1.m, it's saved as a script file. So it's going to look into this on these directories of file and see if it's there. If it's there, it's going to go back there, pick it up, and execute it. If not, MATLAB then searches for the directories in search path in order for problem1.m and then execute it and find. So it will doesn't only search in that current directory. It's going to go to all directories and try to search for that script file and try to execute it. So this is the precedence how MATLAB will work. It's going to go step by step, and it does that with split of a second. So that's why it is very essential, and we're going to cover that. When you name, you really do not want to name your variables same as your script file, and you want to actually stay. When you name your script file, you want to stay away from naming that file with similar to an existing command or existing variables within MATLAB. So this is something that a common mistake that usually happens. System directory and file commands. CD their name, it changes the current directory to directory name, so you can also rename that or change it. dir, it lists all files in the current directory. And dir, their name, again, lists all the files and their name. We went through this. Path, it displays the MATLAB search path. pwd displays the current directory, and which items display the path names of items, if item is a function or file, and identify actually items as a variable, if so. So what you want to be working, you're probably gonna work and save your directory in your P file. I'm very sure every one of you has a P file or Z drive. I'm not sure. Yeah, Z drive. So you can probably save all your work in the Z drive, and especially when you do your script and you want to save all your work, you do that. And also, let's see that you have a problem similar to what I just did, a plotting problem. So what you do, you save that as a script file, and you run the program, and the resultant plot, what you want to do, you want to actually save it as well. You can save it as a JPG file or a PDF file, whatever you want to save it. And because you are going to have to present that in your work, especially when you want to submit your homework. You want to submit it based, like I mentioned earlier, you're going to have a zip file that has all your MATLAB script files in them. And also you're going to submit a PDF file with all the script programs that you wrote with all the results under each one of them. And we talked about that in the first session. If you go back, if you don't remember, please replay the first lecture in this class, because it tells you exactly how I want these submissions. But it would be good practice for you to always define a directory, which is usually would be good, your Z drive to be the directory to save all your work. So you can perform operations in MATLAB in two ways. In the interactive mode, in which all commands are entered directly in the command window, like I just did earlier when I plotted y versus x, and also by running a MATLAB program stored in a script file. And we're going to do that as well. And I was just talking about it. That's how I want you to run all your problems. And you type a file contain MATLAB commands, so running it equivalent to typing all the commands one at a time. The command window prompt, you can run the file by typing the name of that file. Let's see, you establish a script file and you name it exercise 1. Okay, exercise 1. If you want to actually run that program, you can just type on the command window exercise 1 and hit enter. It will do that. Another way is to pull that script file. You can double click on this from your directory and hit run. In that window, there's a run button in the top menu. You can hit it and then it will give you, display all the results in the command windows. And this is where you're going to copy that, copy screen if you want. You can do the clipboard, you can clip that and then paste the results in your Word file, and that you're going to actually convert it to a PDF file and also upload it in your on Canvas. So definitely script file has to be there, but you really need to also, I want to see the solution when you submit your homework. And so that's how you do script file. I'm going to do one example for you that shows you how to do that as well. Inserting comments. The comment symbol may be put anywhere in the line. Again, you want to use the percentage symbol to do this. So for example, if you put a percentage window and do, this is a comment, you'll see that MATLAB will actually ignore anything that you put, because it's not going to take it as a command, because you have that percentage sign that's going to tell you this is only a comment and explanation. So anytime you have a comment in here, it will not, MATLAB will ignore any command in there and just know that you're just commenting on that. So this is something when you write your script, very important to explain your steps by writing a comments, like any other programs like C# and others. You really want to list comments in there. So this is an editor or a script file. If you look in there, this is a script file. It opens, as you can see, when you see percentage sign in there, and then you wrote some text in there, it will actually be automatically highlighted as a green, which tells you that this is only, these are comments, they're not involved in any of the programming. So when you open that, and it's going to give you untitled, and you can always save it and title it with an example, for example, an _1. Yeah, do not use -1, just use _1 or -1 will be, so MATLAB will not be confused. So always use the underscore if you want to have a number in there. And as you can see, this is, you can save that in here, and you can actually, it will actually always save it in the directories, the current directories. So that will be the script file, right? And this is where you're gonna actually cut and paste, and you're gonna cut also in here and paste on your homework Word file, and you have to do this for each of your homework problems. Okay. And you might have also, like I did earlier, you might have a plot in there that you also have to include in your homework as well. So keep in mind, when you're using script files, the name of script file must begin with a letter. Okay, you can start with a number and may include digits and the underscore character, and can much longer than you will ever need. So as long as you follow these guidelines, you shouldn't have any problem saving any files. Do not give a script file the same name as variable. Very important, like I mentioned earlier. Do not give a script file the same name as a MATLAB command. So for example, don't name it cosine, don't name it sine, don't name it something that a function already exists. And you can always check that by using if because you're not gonna know all the commands, you can always see if this function exists. So you use the exist command before you save it. It's a good practice to not do that, because that definitely will create some errors. And you know, the problem with MATLAB, like any other program, it's not writing it, it's debugging it, because to start debugging and finding the problem, that's the time consuming. That's why I follow these procedures, and be careful when you use those commands, and when you do your script, when you save your work. All of this plays a huge role in how much time you're going to spend on this to fix this problems or find errors. So how do you debugging script files? So program errors usually fall into one of the following categories. First is syntax errors, such as omitting a parenthesis or a comma or spelling a command name incorrectly. MATLAB usually, this is the beauty of MATLAB, detects these more obvious errors. So if you're missing a parenthesis, or if you're using a command incorrectly, or something that you did wrong while you're typing your one of the lines of your code or your program, it will automatically tell you that, okay, well, this is a problem. It shows you in a red light, and then you can always go back and fix it. So these are easy to do. The errors due an incorrect mathematical procedures called runtime errors. Their occurrence often depends on particular input data. A common example, if you divide by 0. So this is something more like mathematical, something to do with your own work, your own analysis. So you just want to be careful. You need to be able to find these mistakes as you are solving a problem by hand. You know, you can sometimes you're trying to solve a problem by hand, and then you try to divide by 0, or try to do something mathematically wrong, and you get up with no solution. So that's exactly the same way. Now, to locate program errors, you can try the following. First, test your program with a simple version of the problem, which can be checked by hand. So do your program, work that program by your hand. You don't have to do, if you have, for example, having an array, and let's put x is equal, for example, from 0 to 10 with an increment of 1, and y is equal sine of x. So what you don't want to do this for all 10 of them. You can just choose one of the value, for example, x equal 1, and see if you're getting the right answer. So do that by hand or using your calculator to see if you're getting the same results. Display any intermediate calculation by removing semicolons at the end of the statement. That's what I said earlier, that semicolon, even though it suppresses the results that you do read the one and see, sometimes you want to remove that. And by removing that, you show the results, and you show if the problem with this line or the second line. So by removing the semicolons, it just shows you, it displays values that you you think that it could be the problems with the values that's causing these errors. Use the debugging feature, and there's a debugger editor. You can do that. But anyway, as you write your program, you will notice that MATLAB automatically debugs for you as you go. It will tell you, okay, well, give you options if you're using a command, or if you're using a function, or using, it just tells you exactly how you have to, in what form you have to enter it. So it is actually a self-debug program, and easy to work, as you're going to see when you start working in more complex functions and programming. Programming style, common section, the name of the program and the keyword in the first line, the date creator created, the creator's names in the second line. So what I want to do in this case, you definitely want to put your name. You want to also do what homework, especially when you're submitting your homework, the homework number and the problem number. And you can put definitely the date and the second line. So it doesn't matter the precedence of that. You can do that first, your name first, date, and then do the name of the program or the homework. The definitions of the variables names for every input and output variables. So if you're doing, for example, force equal mass times acceleration, I can define F is force, M is mass, and A is gravitational acceleration. So you can do that if you choose, especially when you're writing a program, a lengthy program. Definitions of variables are very extremely important. The name of every user defined functions called by the program as well. And inputting style, programming style, sorry, input section include input data and the input functions and the comments for documentation. And then you have 3 is the calculation section, and 4 is the output section. Okay, so all of these needs to be included in your homework submission. So again, your script, your calculation, and the output if they have a plot or anything, or table or anything else. Some input and output commands that also can be used. So display A, it displays the context, but not the name of the array A. Display ABC. Again, you see those strings there. Display the text, string enclosed within single quotes. X is input ABC. Display the text in quotes, waits for your input, and something we'll be using as well. Input from the keyboard and stores it in the value of X. X input ABC, and then the comma, and then you have strings S, display the text in quotes, waits for user input from the keyboards, and store the input as a string X. So we definitely be using most of these commands later on with some examples. So example of a script file. Let's see if I have that. So let's look at this example. The speed of V of falling object dropped with no initial velocity as given. A function of time, t. V is equal g times t. The velocity is equal to gravitational acceleration times time. Remember, these are motion, it's accelerated motion. So the velocity is a function of time, it's a linear function of time. So plot V as a function of t for t is equal to 0 to t final, where t final is the final time entered by the user. So depending on the final time, we're gonna you can define that by asking that user what is the final time you want, and then that would change the plot based on that and the time value that you enter. So how do you write script? You can start, this is a script file. You can start by writing the name of that program. So program falling speed.m plots speed of a falling. You can actually explain that if you want. You can create it on, for example, May 5 date, And then you can also define the input variables. Input variables is t final, is defined in time and second. Output variables is the time and also the velocity. So this is a very self-explanatory script file because it tells you everything. It tells you who wrote the program, the time, and describe the program itself. It describes the input variables that you're going to enter, and also it describes the output variables and gives you also units when you're trying to solve. Now, when you write the programs, there's a couple of things that you want to also define as, for example, G, parameters, value, which is G is equal to 9.81. Again, you have that semicolon because you're suppressing that. Acceleration in SI unit. Again, it's meter per squared second. Input section, T final. And T final, we're using the input command, parentheses, and then we open the string, enter final time in second, and you close the string with a parenthesis. So what we're saying, we're asking MATLAB in the command window to ask us what is the final time. And we are going to enter that final time. Let's see after 10 seconds, which is going to put 10 seconds, and then MATLAB will take that final time and apply it as on the script. So create an array. Calculation, for example, the section, calculation section here, dt is equal T final divided by 500. Now you can change that if you want to 1,000. It doesn't matter. T final divided by 1,000 depends how many steps you want. Here, the author chose to have 501 steps time value. So dt is equal to T final. Remember T final, we're going to enter it, and based on that value, it's going to divide it by 500 and give us 501 values. Now T is equal, this is where we create the arrays of T, is equal Z, 0. 0 is the initial value. Then you have the column. dt is the increment, and column T final is the final value that we enter. And then again, we do the semicolon, and that will create the array for T, because remember, you are going to plot the velocity versus time. And then we're going to compute the speed value. Speed is equal G dot G times T. And also, again, we use the semicolon there to suppress the value of the velocity, because we're not really interested in listing the values of the time and the velocity. We're interested in plotting that. So the output section, again, if you notice, we always use those percentage sign to just comment there. And in your script, you'll see that these are highlighted in green. And then now we want to plot T versus V. Again, always T, that will represent the x-axis, they will represent the y-axis. Plot T versus V, x label T in seconds. Again, this is the units, and y label V meter per second. So if you do that, I don't think I have the plot, but you can try on your own, and then you'll see that you'll have a plot in there. It should be actually a linear plot, right? Because V is a linear function of the time. You'll see that a straight line. All right, so getting help from the textbook. Again, as far as MATLAB commands, there's zillions of reference online. You can use that if you want, or just go to that directories that is available for us. Just type whatever command you want or any hint word that you want to see, and then it will bump you to any command that you want or any function that you're trying to find. And it tells you exactly how you have to insert it correctly. So getting, again, help from MATLAB, the function, you can, again, use the search for function, that one that I highlighted earlier for you. It tells you that. And as you can see, this is something, MATLAB is a self-debugger. It will, if you hit plot, it will give you how automatically how MATLAB wants you to apply this command. So it will actually show you how to do it. And if you made a mistake, it will automatically give you a red highlight that you did make a mistake. It's really simple to work with. You get used to do it. I'm very sure you've done this in Comp 1, but again, because we're going to be doing a lot of problems, you feel more comfortable working with this program. Again, MATLAB help function, like I said, help function as underscore name. You display command window with a specified function name if you're trying to find a function. Look for topics, you can do that as well. Display the command window, brief description for all functions, whose description includes the specified keyword topic, or doc function underscore name opens the help browser and it tells you, what function name they want. I don't usually use this. All I do is just go to that help functions and the main tool bar and just type whatever help I need, and it will give you that automatically. So steps in engineering problem solving, and this is, we're gonna follow this a lot all semester. First, we're gonna have to read the program, the problem. We understand the purpose of the problem. Collect the known information. Realize that some of it might later found to be unnecessary. So we're gonna have to try to see what we have information. Determine what information you must find. So we might be given an input and want to see what is the output that we want. Simplify the problem only enough to obtain the required information, and then you state your assumptions that you make. Draw a sketch and label any necessary variables. Determine which fundamental principles are applicable. Like we just did the dynamic function where velocity is a function of time. So use a dynamic principle. 7, think generally about your proposed solution approach and consider other approach before proceeding with the details. Label each step in this solution process. If you solve the problem with the program, hand check it. Try to solve it by hand, at least one of the calculation you do by hand to make sure that what you're doing is correctly. And if you're making mistakes, you can go back and debug your program. Then perform a reality check on your answer. Does it make sense? This is something that you do if you use a program or if you don't use a program. You're always gonna get a result and see if this whatever answer you get is making sense. If it's not making sense, that means you really made a mistake. You have to go back and fix it. So estimate the range of the expected result and compare it with your answer. Do not state the answer with greater precision than it is justified by any of the following: the precision of the given information, the simplifying assumptions, and also the requirements of the problem. Interpret the mathematics. If the mathematics proceeds multiple answers, so if you're getting a imaginary number, why am I getting imaginary? If I'm getting a negative number for time, does this make any sense? So you really want to always look at your result and make sure that your results make sense. Steps for developing a computer solution: state your problem consciously and specify the input data by using the program, and you can actually always comment and describe your input data like was done earlier. Specify the output information, define those variables that you want to output, and work through the solution steps by hand or with calculator to see if you are going to get very similar results. Steps for developing a computer, still we're doing this. This is step 5 is write and run the program. 6, check the output of the program with your hand solution. Run the program with your input data and perform a reality check. Check if this makes sense. See if your results again making sense. If you will use the program as a general tool in the future, test it by running it for a range of reasonable data values. So if you wanna, and this is something that you are going to learn when we also say functions and see if and you use those functions and some script files. You also want to see if these functions can be used in a later time and make sense if it works with the other scripts. So that's why you want to test it in different types of data to see if it works for all data. So that is actually that should summarize this chapter, and we are going to do more problems with the next sessions. We're going to start doing problems, plotting and creating arrays. So that should do it for this session. And why I'm trying to limit the value, the time of each session, so you guys can maybe by minimizing the time for the session, just make it a little bit more easier for you to grasp the concepts here. So next time we'll do another lecture, and we'll do more. Our lecture will involve more problems, in-class problem or online problems as well. So please, like I mentioned earlier, make sure that you do the. There's a couple of examples on this lecture that is in there. I did one of them, the plot, but there's another one with the velocity versus time. Please do that on your own. Go open MATLAB, do the program, and see if it works. If it doesn't work, redo it. Make sure you debug it. And this is no, these are review times because you're supposed to be able to do all of this. That's what you learn in Comp 1. I'm just giving you a chance to go back and review all of this before we start covering the more complex chapter. Well, thank you very much, and I'll see you in the next lecture. Thanks.